Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to Kids Planet with Urwa, where we think together, explore the universe, and most of all enjoy learning. Science World की Tale of the Universe पे से, and today we will be starting the subtopic homogeneity of the universe from Unit 3. So previously we learned that there were some questions that could not be answered by the Big Bang, but were answered by the inflation theory. Homogeneity of the universe is one of them. जो स्टडी थी ऑफ द कॉस्मिक माइक्रोवेव बैकग्राउंड वेव्स, उसने आल्सो रिवील किया अनदर वंडर, वो ये कि और यूनिवर्स हैज ऑलमोस्ट द सेम टेम्परेचर एवरीवेयर. ये अज्यूम किया जा सकता है कि जो टेम्परेचर है ऑफ एंटायर कॉफी इन द सिंगल कप ऑफ टी इज द सेम, और अगर आप उसमें स्पून रखें फॉर अ सफिशिएंट अमाउंट ऑफ टाइम तो द स्पून विल आल्सो गेन द सेम टेम्परेचर. However, ये एक suitable assumption नहीं है for two coffee cups that are separated by a distance. Generally, there is no justified reason for multiple distant objects to attain the same temperature. जो distant regions of space in opposite directions of the sky इतने far apart हैं कि अगर आप assume करें standard Big Bang expansion, they could never have been in casual contact with each other. This is because the light travel time between them वो exceed कर जाती है the age of the universe. Yet जो uniformity of the cosmic microwave background temperature वो tell us करती है कि ये जो regions थे they must have been in contact with each other. Since your universe has a finite age and light travels at a finite speed, information travel नहीं कर सकती faster than light. This means कि जो any two regions of space that are not in casual contact are completely separated और interact भी नहीं कर सकते. Yet the universe appears to be homogeneous in all directions. कोई भी mechanism नहीं है to cause the various separated regions of the universe to have the same temperature, जैसा observe किया जा रहा है by the isotropy of the background radiation. लेकिन जो inflation suggest करती है, it is a burst of exponential expansion in the early universe. It follows that जो distant regions थे वो actually much closer together थे prior to inflation than they would have been in only the standard Big Bang expansion. Thus जो such regions हैं they could have been in casual contact prior to inflation, और फिर उन्होंने उस वक्त attain किया होगा uniform temperature. बेटर अंडरस्टैंडिंग के लिए हम अज्यूम करते हैं कि यूनिवर्स है वो एक्सपैंड नहीं कर रही. नाउ इमेजिन करें एक फोटोन रिलीज हो रहा है वेरी अर्ली इन द यूनिवर्स और वो जर्नी कर रहा है फ्रीली अंटिल इट हिट द नॉर्थ पोल ऑफ द अर्थ. नाउ इमेजिन करें कि अनदर फोटोन था वो उसी टाइम पे रिलीज हुआ बट इन द ऑपोजिट डायरेक्शन देन द फर्स्ट वन, वो हिट करेगा अर्थ एट द साउथ पोल. क्या ये जो दो फोटॉन्स हैं दे कुड एवर can they exchange any information from the time they are released? Clearly not, because the time required to send information एक photon से to the other photon, it would be 2 times the age of the universe. The photons are casually disconnected and outside of each other's horizon. ये जो photons है वो communicate नहीं कर सकते with each other unless inflation जो है it took place during the very early universe. However, we observe कि जो photons हैं from opposite directions they must have communicated somehow, because जो cosmic microwave background radiation है it has exactly almost the same temperature in all directions over the sky. जो इन्फ्लेशनरी थ्योरी है वो सजेस्ट करती है कि जो यूनिवर्स है वो एक्सपैंड हुई एक्सपोनेंशियली इन अ शॉर्ट टाइम पीरियड आफ्टर द बिग बैंग. इससे पहले बिफोर द पीरियड ऑफ इन्फ्लेशन जो इंटायर यूनिवर्स थी इट कुड हैव बीन इन कैजुअल कांटेक्ट, और उस वक्त उन्होंने इक्विलिब्रेटेड किया होगा टू अ कॉमन टेम्परेचर. Widely जो separated regions आज हमें दिखते हैं they could have been very very close together in the very early universe, explaining कि why जो photons हैं from these regions इनका same temperature होगा. एक simple model for this expansion of the universe is to consider कि जो inflation of a balloon. A person at any point on the balloon अपने आप को consider कर सकता है as the center of the expansion, as all neighboring points are getting further away. Now these are two illustrations. So this is the example that I explained of the photon, of the photon example, and ये है एक detailed all sky picture of the infant universe created from the 9 years of WMAP data. जो image है वो reveal कर रही है the 13.77 billion year old temperature fluctuations, जो कि show की भी हैं as you see temperature differences. You can show as color differences that correspond to the seeds that became to the galaxies. ये जो signal है the signal from our galaxy was subtracted using the multi-frequency data. ये जो image है वो show कर रही है a range of 200 microkelvin. So that's all for today. Thank you.